I have a problem. No, it's not an addiction to buying tools, not shiny new things, not a midnight obsession for all things woodworking. Okay, maybe I have multiple issues. But that's not the problem we're here to talk about today. I don't have enough space. But now, with more tools on the way, I have to run that plan by my wife.
Okay, but we made a deal when we moved in. You promised I would get to park my car in the garage. I don't think getting more tools is going to work.
Hello? Hello? Jeremy? Hello?
Yeah, that deal is about to get tested. With a lathe, a bandsaw, and a Tormek on the way, I'm going to need to figure out how they fit in a single car garage. And this shop isn't getting any bigger. So here's the plan. I'm out of floor space, so everything has to store away. So she could park. The bandsaw needs a stand, so I'm building a swinging platform. Out when I need it, flat against the wall when I don't. The lathe and the Tormek need a bench, but there's nowhere to put it, so it goes up. A retractable shelf on rails, pulled up to the ceiling when it's not in use. Everything tucked away out of the way of the car. And while I'm at it, I'm fixing the lighting, because with one light at the back, I can't see a damn thing. It's good to be back in the shop again. Well, I never really left, but it just seems like it to you because it's been a little while since my last video, but more on that later. It's also fun just to work with some pine. No milling or sanding, just design something and stick build it. Alright, so here I'm starting with the swing stand for the bandsaw. My last bandsaw was one my dad had passed to me, and it was probably his dad's or somebody's dad by the looks of it. You couldn't even get the right blades for it anymore. Frankly, it was just dangerous. Plus, I had nowhere to put it, and it was really heavy, and I'd end up either using it on the ground or up on the workbench, which put the cut at face level. Not ideal. The stand won't just fold away, it will also be set to the perfect working height for me. Here you're just seeing me break down some 2x4s and building up the platform that will support the bandsaw. But before I get too far into this, I should probably explain how we got here. For years, we lived inner city. I never really had a shop. It was always just a dream that one day I'd have a space of my own. So when we bought this house, I decided it was happening, even if the garage was this small. Here, let me give you the 5-cent tour. Now please excuse the crudity of this model. My wife Jenna doesn't drive an R8, she drives an A3, but I figured if we were dreaming, we might as well take a few liberties. As you can see, there's just enough room for her to park, so everything has to move. I built this rolling workbench. It comes out when the car's gone. It's a flat work surface, but it also holds my 3 main tools. Table saw on one end, miter saw in the middle, flips up, planer on the other, stores on its side, and then locks in place with a French cleat. With the cart in, there's not much room, but we do have a little bit of space to work with. The bandsaw could go here, along the wall. The lathe and the Tormek can stow up here, near the ceiling. So we will start with the bandsaw stand on this wall. So I mentioned it's been a little while since I posted. I've been spending some time learning some new techniques and trying to get a little better at telling these stories. I've been taking some tutorials online to learn how to create some of these animations you've seen so far. But that's not the only thing I've been learning recently. Regarding the lathe, there's a little problem. The last time I used a lathe was probably 20 years ago, and I'm pretty sure I made one bowl. So before I start building a whole system around it, I figured I should probably relearn what I'm doing. I've been going through some of the woodworking content on Woodworkers Guild of America, who happen to be sponsoring this video. And when it comes to something like a lathe, you really can't just fake your way through it. I've been a tradesman for nearly 20 years, and one thing I can tell you for sure is that you always learn better and safer from people who already know what they're doing. From day one, I've always been a bit of a sponge, picking up things from more experienced guys, watching how they work, and sealing these little details that actually matter. And that's what I like about Woodworkers Guild of America. It's not just random videos, it's experienced instructors sharing decades of knowledge, walking through things step by step. So instead of guessing or finding out the hard way, I've been using it to get my bearings back on turning, and especially brushing up on safety before I dive into this. Woodworkers Guild of America is an online resource for woodworking instruction, ideas, and information. They have courses on things like bandsaw techniques, joinery, jigs and fixtures, finishing, pretty much everything you'd run into in a shop like this. If you want to check it out, the first 1,000 people watching this video to use the link in my description will get a full year of premium membership to Woodworkers Guild of America for only $149. The offer is valid to new members only. Alright, thanks Woodworkers Guild of America for sponsoring this video. Okay, so up until this point, you see me build out the frame for the swing stand, a horizontal base, and some vertical bracing. I also added some plywood gussets to tie everything together, and that's what's going to carry the load once this thing swings off the wall. Now it needs a way to mount, so I'm building out a bracket that will mount to the wall, laminating some 2x4s above and below the pivot point. I'll tie it all together with this plywood backer that'll span across 3 studs. I put a few playing cards between the moving parts for some clearance, and then I just glue and screw everything in place. Alright, so here's how it works. Like I said, we will mount it on this here wall under these here clamps. We will mount the bracket to the wall on some plywood spanning multiple studs with a steel rod for the pivot. The gussets carry the weight of the bandsaw when it swings out and latches lock it in place. And I'll add another set to hold it against the wall when it's stowed. Next, I rip some plywood for a backing plate to span across several studs. I glued the bracket on and pumped a bunch of screws in from the back. The right side lands on a stud, which will provide some rigidity. For the pivot, I'm using a 1/2 inch steel rod with some steel spacers, so I center some holes and drill them out with the doweling jig. I'll glue the spacers into the hole and the rods fit perfectly inside. I'll grease them a little bit, but they spin easily. I use the same technique for the pivoting miter saw section in my workbench. Before it can actually swing, these corners need to go, so I mark the arc of the movement with a pencil, cut them back with a jigsaw, and clean it up with a sander so that the brackets can rotate freely. I repeat this process for the wall bracket. Probably would have been easier to do this before it was mounted, but it's too late now. Thankfully, I have a really long bit from the shelf project that allows me to drill through both pieces using the jig as a guide, so it'll be perfectly aligned for the rod. Then I round off the bracket corners too so that the stand can pivot freely. This part especially should have been done first, but I hack my way through it. Then I set the spacers with CA glue, hammering them into place. These spacers are 1.5 inches long, so they're the same width as a 2x4. And that's mainly why the studs are on their sides in both instances, so I doubled them up for some more strength. This bottom one was really awkward and I was cursing myself for not doing this before it was on the wall. I drilled out the holes in the arms of the stand, simply measuring and using the doweling jig again. Do the top and bottom and then glue those spacers in too, tapping them in before the glue sets. Then I cut up some rod with the grinder. And I position the stand to align the holes. I put the rod into the chuck of my drill here, which allows me to hold and wiggle the stand as the rod slips through the inserts. But it gets hung up at the end from too much friction, so I have to hammer it home. And then the hammering caused some mushrooming on the end of the rod, so I have some difficulty getting the collar on. I use these collars just to hold the rod in place and stop it from wiggling out over time. I'm happy with the way it's swinging, so I sheet the top with some 1/2 inch ply, and I screw it down. I run a router with a roundover bit around the edge to prevent any splintering or slivers. Then I put some of these over center latches on to lock it in the open position when you're using the bandsaw. They showed up a little smaller than I expected, so I might have to swap them for something bigger one day. Then it's time to open presents. Opening the box is equally as exciting as buying the tool. I'll set the bandsaw up off camera, but I'll get it into position so we can bolt it down. I use a brad point bit through the mounting holes to mark the plywood where I need to drill. Then I drill out the holes for some threaded inserts. I always use CA glue on my inserts in my projects. You might not need it, but bolts have a tendency to seize to threads, and when that happens, the force to break them loose is stronger than what's holding the insert in the wood. So instead of backing the bolt out cleanly, you rip the insert right out with it. Now you've got a bolt stuck through the base, but the insert hanging off the end, and you're screwing around with pliers trying to get it off, and that would just be a pain. So a little CA glue will keep the insert in the wood. Now it was time to build the part I'd been excited about for quite some time. This idea had actually been living in my head for about a year, and weirdly enough, it started on leg day. I was at the gym thinking about how to cram more tools into the shop when I noticed the big linear rails on the leg press. At first, my brain went to some kind of custom flattening jig, but as I eyed up the pulleys that moved the weights, it kept wandering, and I landed on something much better. A retractable shelf built on linear guides. I'd floated ideas for something that could fold down from the ceiling, but for a lathe, a rigid bench just makes a lot more sense. It needs to feel solid while you're using it, and this felt like the sweet spot. It's practical and strong, but it's also easy to stow out of the way. So here you're seeing me mount 2 vertical 2x4s that will support each rail. I align them on studs and pump 4.5-inch structural screws through the 2x4s and the same through the rails themselves. I bolt 2 guide bearings through a scrap board and use that as a spacing jig. I slid the jig over the first rail, positioned it at the bottom, fit the second rail into place, and then pinned it there. Then I just work my way up, leveling, checking the fit, and fastening as I went. This way I'm not just measuring rail to rail with the tape, I'm using the actual bearings to set the spacing for me. The goal isn't necessarily just parallel, it's smooth travel. And this is just going to stop the rack from binding and fighting itself later, which would spell trouble. And everything seems to be sliding smoothly with a quick check. Next I have to build the shelf itself. So I'll buck up some 2x4s and I'll frame out 2 sections. There'll be a vertical section that mounts to the wall and a horizontal section for the tools to sit on. I know all of this seems like some great lengths to go to, but it's more than just convenience for my wife. The A3 is a convertible with a soft top, and that's not something you can just leave sitting out in the ice and snow through a Canadian winter. So at the end of the day, this garage still needs to function like a garage, and I still need my shop, so here we are. Hopefully one day I'll have a standalone shop, but for now, I just gotta make the most of the space that I have. To stiffen up the rack, I added these built-up beam sections at either end. The 2x6s on the back are the real anchor here. They give me something meaty to pass bolts through and into the guide rails, so the rack isn't just kind of hanging on by some plywood, it's properly tied into the structure. I finished gluing and screwing the framing, clamping the studs in place while I screw them together. Once I sheet these stud walls with plywood, it's going to be super strong. I mean, this is basically how you frame a house, right? Except we've added glue. So this is the part that fastens to the rails, kind of like this. And if that's all still a bit hard to visualize, here's how it goes together. We mounted the studs to the wall and the guide rails to that. The guide rails go on, then a 1/4-inch steel plate as a washer. Then 1/2-inch ply and the stud wall with the other section mounted at 90 degrees. Then 8 bolts per corner through another 1/4-inch plate, sandwiching the 2x6 beam. We'll sheet the top and then add some plywood gussets. Then a hook, some pulleys, and a winch. A cable, and 2 pulleys on either end of the rack. When descended, it'll rest on 2 feet with a neoprene lining. It'll house a tormek and a lathe. It'll store at the ceiling when the car is parked. Now I need to frame out the second section, which will tie in perpendicular to the vertical rack. I hope you've been enjoying those animations and that they've helped visualize the project a little easier as it's coming together. If you have any thoughts on them so far, feel free to let me know in the comments. I genuinely love the feedback. A few people have asked if there's a way to support the channel a little further, so I've set up a Patreon with a simple base tier for now. It's just there for anyone who wants to support the channel a little bit. There's no pressure at all, but if you do choose to, I really appreciate it more than I can say. There's a link in the description if you are interested. Here I'm mounting some of these pulleys to the ceiling. Each one fastens with 2 screws into a ceiling joist and 3 into the wall stud, so they're anchored from both directions. Then I'm mounting this worm gear winch on a 2x6 that will span across multiple studs. I'll pass structural screws through the 2x6 and through the winch base itself into the wall, but I also add 4 bolts through the board for extra stability. I got pretty lucky with the framing here. I'm able to catch a beam that the right rail is mounted to, and there must be a really large beam on the right side of this board, so I sink in lots to be safe. I mount some plywood backing for the anchor that the cable will attach to, and I mount the anchor with 6-inch long lag bolts. I did pre-drill these and grease the bolts so they don't split the joists on their way in. I spent a lot of time making sure all of this hardware stayed well within a safe working range, so here's a quick rundown. The weight of the rack, the lathe, and the sharpener is no more than 200 pounds. The hook and cable are rated for 10,000, the winch is for 1,500, and the pulleys are rated for 500 pounds each. Because this uses a moving pulley, with the cable tied off at the ceiling, the load is effectively split in half. That means each side only carries about half the total weight, so the hook, hoist, and cable are all seeing no more than roughly 100 pounds. The pulleys and their mounting points can see somewhat higher loads because of the redirect forces, but everything in the system is still rated well beyond what it should ever experience here. And that leaves me with a safety margin that I'm comfortable with. With the back sheeted, I line the rack up to get ready to mount it to the rails. You can also see the pulleys attached to the back of the rack here. I installed those off camera because at this point you've pretty much seen the process. It's the same idea as the hoist mounts, with bolts passed through the structure to tie everything securely. From there, I attach the rack with bolts to the guide bearings, using these steel plates as a large washer. Like I mentioned earlier, the rack structure gets sandwiched between 2 1/4-inch steel plates. Before they go on, there's these little set screws that set the tightness of the guide bearings, and I set them where I want them using some purple Loctite so that they don't rattle loose over time. Then I bolt the rack to the guide bearings. I skip showing all this because there's 32 bolts, and once you've seen one, you've kind of seen them all, but I threaded them all in and tightened them up with an Allen key. At this point, with the rack mounted, I'm pretty excited to see how it slides. It's got some weight to it, but it feels super stable, and there's no catching or binding, so I get a little more excited to attach the cable and get the winch running. I went with a synthetic rope here because it winds tight and it plays nicely with small radius pulleys. Compared to what this setup will ever ask of it, it's living a pretty easy life. The actual loads here are pretty modest, so there's lots of margin built in. After all, we only need to lift about 100 pounds because of that mechanical advantage. Then I just fish the cable through each pulley and I'll attach it to the winch drum. I ended up with quite a bit of rope here, which actually works in my favor. More wraps on the drum generally gives the winch a better hold on the line. Then I feed the line through the drum, tie it back onto itself, and wrap a series of hitches around the spool. That way, once there's load on the line, it cinches down on itself and grips the drum more tightly. Then, with the leather gloves on, I apply tension while I wind the drum. It's important that the winch is wound under tension or the rope can bind on itself later. Then I gave it a test run and listened for anything I didn't want to hear. Any binding, any creaking, any signs that something was fighting that movement. But everything rolled smoothly. Also, I hadn't mentioned it before, but this is the perfect application for a worm gear winch. The mechanism is designed so the drive can turn the drum, but the drum can't just turn the drive back on its own, so the rack stays put instead of backing itself off and crashing to the ground. Now you're seeing me sheet the top and notch out the sides with a jigsaw to allow for the rails, while overhanging the rope at the back to keep some debris off the rope. Then I'll just add some plywood gussets for some extra strength, and I'll glue and screw them in place. Then it's time to test out the system under some load before the expensive equipment goes on. It seems pretty sturdy, so I do what they always tell you not to do and I take a brief ride. I add some over-center latches that will hold the weight of the rack to the wall when it's in the lowered position. This will take the weight of the equipment off the bearing blocks when I'm using the tools and holds it tight to the wall. I add some Loctite to the threads to keep the latch hook from spinning after I set the proper tension. Then I need to build some kind of safety mechanism for the system so that when it's raised into the stowed position, it can lock in place and the load can be removed from the rope. Not because I'm worried about the rope, but because the safest place for a stored load is on a mechanical lock, not hanging on the hoist line. I want these deadbolts to be automatic, so that when it's raised into position, the bolts automatically engage so that I don't have to walk underneath the load to safe it out. So I cut up some steel with the angle grinder and remove some material so that I can make a clean bend at the corner of the taper. The goal here is to create a ramp that would push back a spring-loaded deadbolt as the rack is raised into the stowed position at the ceiling. That way, the bolt could ride up the ramp, compress the spring, and then snap into the hole once it reaches the top. So basically I'm lining the ramp with steel so that the bolt would slide cleanly without getting hung up and not slowly wear a groove into the wood over time. I'll fix the steel to the wood with epoxy, so I mix some up with some scrap wood and spread it on the tapers like a Neanderthal. I clamp them up and set them aside to cure while I work on the feet that will support the weight of the rack when it's lowered and hold it at a proper working height. They're different heights because the garage floor isn't level. I line the point that will contact the rack with neoprene for a soft landing and to absorb vibration from the lathe. I'm fixing some plywood to the feet so I can attach them to the verticals that hold the guide rails. I fit them in, screwing them in place, and I'll add another over center latch to hold the rack down while it's in use so there's no movement when the lathe is being used. I think this should reduce any potential vibration as well. Next, I need to set up the lathe so that I can set the lift as close as possible to the ceiling so I can figure out where to put the safety latches. It's pretty heavy and awkward, so I scoot the bench over to the lift so I can just slide it on without lifting it. Then it's time to open more presents as I unpackage my new Tormek sharpening system. I'd been wanting a proper sharpening system for a long time, but something like this takes a bit of saving up. Ultimately, my brother convinced me because he got one and swore by it. This isn't sponsored, by the way, though I did reach out to Tormek because I genuinely am impressed with it. Before this, I used the Scary Sharp sandpaper method, which works incredibly well, and it costs a whole lot less. It just takes a lot of time, and so I had to find time to sharpen, and that usually meant I was working with tools that weren't as sharp as I wanted. It's a big investment, but it's kind of like investing in your entire tool set all at once. Here you're seeing me attach the spring-loaded deadbolt after gluing the bolt ramps to the verticals. You can see they lock in the compressed position for lowering, and then you extend them while you're raising it, and the bolt rides along the steel until it locks in place. By the way, I'll put a link in the description to a video about that Scary Sharp method if you're interested in something cheap but still effective. Then I mark out the perimeter of the lathe base for some neoprene, and I mark the holes for the mounting points with a brad point bit. I drill out the holes, and I bash in some T-nuts with a hammer. I added a layer of neoprene under the lathe base to help dampen the vibration and take the edge off any resonance that might come from hard mounting the lathes to the rack. I add some neoprene lined washers as well. The board I mounted the winch to takes up some valuable real estate on the wall, so I decided to make use of it. I put together a quick holder for my gouges and chisels by marking out evenly spaced holes on a strip of plywood and drilling most of the way through with a depth stop. I add a little CA glue to each of the holes, press in some rare earth magnets, and set everything with activator. It gives these tools a dedicated place to live that's right near the bench and the lathe, which makes them easy to grab whenever I need them. For the final touch, I put my electrical ticket to use and added some lighting. I blast out holes with a 4-inch hole saw, geared up with some PPE, and got to work. I went with these pod lights for a couple of reasons. First, they're cheap. I think all the lights in the wire came in at under $100 from the orange store, but more importantly, they're simple to install. Plus, evenly spaced pot lights do a much better job of keeping shadows off the bench while you work. As I fished wire from hole to hole, tying each light back into the existing fixture at the far end of the shop, I realized that this little expansion was finally done. All that was left was to tie in the power, and for the first time, I got to see the whole thing the way I'd pictured it in my head for months. Every part of it, the tools tucked away, the floor opened up, the place lit up, this little shop doing more than it ever had before. It felt like watching an idea become a place. My place. And then it occurred to me that there's this idea that bigger spaces make better work, that better tools make better things. But the best ideas, they don't come from what is, they come from what could be. And yeah, it would be easier with more space, more room to move, every tool sitting out ready to go. But when you want something badly enough, you start looking at things differently. Not just for what they are, but for what they could become. When you're a kid, that comes naturally. A few blankets become a castle. They see worlds where others see walls. Somewhere along the way, it gets harder to think like that. You start seeing limitations as the end of an idea. But they don't have to be. When you want something badly enough, you find a way to make it happen. You build around the problem. And somewhere in that, the limitation stops being the thing in your way and starts becoming part of the idea. So no, the shop didn't get any bigger, but it got better. Not because there's more space, but because the space has purpose now. And I think it's not about how much space you have or how many tools you own. It's about what you do with what you've got.